Alright, I'm hoping this is going to help us with adding fractions and working through these problems a little more independently. We practiced a lot adding fractions already, so I think we're getting pretty good at it. What's a little different about this is we're adding mixed numbers. So when we're adding mixed numbers, I gave you two ways to figure out how to do it. The way I recommended and the way we practiced in class was to first make your number an improper fraction. After that, you just add the fractions or subtract the fractions, whatever the problem says to do. And then last, we have to, because we're given mixed numbers, so we want to give our answer back as a mixed number. So then we have to make our answer a mixed number. And then this does, and the directions tell us that we need to put in simplest form. So once we get our equivalent answer, we need to put this in simplest form, so we'll simplify the fraction. So we're just renaming the fraction with smaller numbers. Okay, looking at number 1, we're first going to turn our mixed numbers into improper fractions. So we've got 2 times 5, which is 10, and then 10 plus the numerator is 3. So we have 13 over 5. Okay, and then we've got a plus sign. I'll put the plus sign down. Okay, and we've got multiply the whole part in the denominator. So 1 times 5 is 5. 5 plus 4 is 9. And then 9 over the old denominator was 5. Okay, so we're adding 13 fifths plus 9 fifths. The first fraction is talking about fifths. The second fraction is talking about fifths. If I say I have 13 soccer balls and 9 soccer balls, I would tell you my answer in soccer balls. I've got 13 fifths plus 9 fifths. I can express my answer in fifths. So the denominator is what we're talking about. The numerator is how many of them I have. Okay. So once you've got the same common denominator, which we have, then you can just add straight across. So 13 is positive, plus 9 is positive. When I'm adding and subtracting, it's same sign, add, different sign, subtract. Since these are the same signs, we can add them. 13 and 9 makes 22. So we've got 22 fifths. We want to put our answer now back as a mixed number because the question gave us mixed numbers. Okay, so to make this a mixed number, I need to know my multiples of 5. So we've got 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and 5 times 5 is 25. Okay, so how many times will 5 go into 22, but without spilling over? And it looks like the most 5s we can fit is 4. We can fit 4 5s into 22 without spilling over. So the whole number is 4. Now when I've got 4 wholes, I'm using 20 fifths. When I have 4 wholes, we're using 20 fifths. I had the 22. I had 22 fifths, and I'm using 20 fifths. So I need to subtract. What's the difference? How many do I have left over? 22 minus 20 is 2. So we'll have 2 fifths left over. So I've got 4 and 2 fifths. 2 fifths is already simplified, so I don't have to simplify further. Now looking at number 2. So these are mixed numbers, and we want to make them not mixed numbers. We want to make them improper fractions. So we multiply the denominator and the whole part of the number. 3 times 6 is 18. 18 plus 5 is 23. So we've got 23 over 6. And then I'm just going to write down the minus sign, minus 1 1/6. So minus, multiply 1 times 6, and that's 6. Add the numerator 1 is 7, so 7 over 6. So I've got 23/6 minus 7/6. So if I'm talking about sixths here and sixths in the next fraction, I can express my answer in some form of sixths. Okay. This is 23 red houses and 7 red houses, so some number of red houses. But instead of red houses, I'm using sixths. Okay. Now I can, because I have the common denominator, I know what I'm talking about. I just have to figure out how many of them there are. Okay, so we've got 23 minus 7 in the top. I know that says 23 minus 7, and that is a normal minus problem. I really want to focus on our adding and subtracting rules with negatives, because that's something that we're still working hard at, because negative numbers are still kind of new. 23 is a positive number, and when it says minus 7, that's really a negative number. When we're adding and subtracting, if I have the same signs I add, different signs subtract, keep the sign of the larger number, then we'll be exact, right? These are different signs, so I am going to subtract. So I'm going to do 23 minus 7. You can't take 7 from 3, so you're going to borrow 10 ones from the 10 spot, making 2 into 1. Now I have 10 ones that I can put in the ones place, so 3 becomes 13. And then 13 minus 7 is 6. Okay? And then 1 minus nothing is 1. So 23/6 minus 7/6 is 16/6. Keep the sign of the larger number. Well, the larger number was 23, and that's positive. So our final answer, well, our improper fraction answer is 16 over 6. I'm going to make it a mixed number now. To make it a mixed number, I need to know my multiples of 6, because I'm answering how many times will 6 fit into 16. I know that 6 times 2 is 12, so I'm going to start with 6 times 2. That's 12. 6 times 3 is 18. Okay. We've got 6 times 3, 18, that's too big. So 6 will only fit into 16 2 whole times. If I'm using 2 whole numbers, then I'm really using, so I'm using 2 wholes. That's the same as 12/6. Using 2 wholes is the same as using 12/6. I had 16/6. I'm using 12 of them. So I need to know how many are left over. 16 minus 12 is 4, so I've got 4/6 left. Okay. 4/6 is something I can simplify, so I'm going to try and simplify it now. I can simplify, a common factor that 4 and 6 have is 2, because they're both even. So let's divide both the numerator and the denominator by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So this is the simplified version of 4/6. So instead of writing 2 and 4/6, I'm going to write 2 and 2/3. Okay. Looking at number 3. I really gave you all 11 problems. Number 3. So changing our mixed numbers to improper fractions. We've got 4 times 4 plus 3. 4 times 4 is 16 plus 3 is 19. So 19 over 4. Plus the other improper mixed number is going to be 2 times 3. Denominator times whole is 6. Plus numerator, 6 plus 1 is 7. 7 over 2. Okay. Previously, I was able to add straight across because I knew what I was talking about. in this problem, my first fraction talks about fourths, and my second fraction talks about halves. Those are not the same. I need to make them the same. And I know I can multiply 2 times 2. So I can multiply the denominator of my second fraction by 2 and get back the same number that I have in the first fraction, 4, right? That leaves me with 4. To go from 2 to 4, we multiplied by 2. So let's multiply on the top also. Well, 7 times 2 is 14. So I've renamed my problem. Now I have 19 fourths plus 14 fourths. Okay. Now that both of the denominators are the same, 4, I know that I can express my answer as a form of fourths. Okay. To get the top number, I just add the top then. 19 is positive, 14 is positive. When I add, if the signs are the same, add. If the signs are different, subtract. Same sign, add. Different sign, subtract. Keep the sign of the larger number, right? They're the same signs, so I'm going to add 19 and 14 get added then. 19 and 14 is 29, 33. 19 and 14 is 33. From there, we're going to ask ourselves, we need to go to an improper, we have an improper fraction, but we were given mixed numbers. So we want to make this back to a mixed number. Making this back to a mixed number, I'm asking myself, how many times does 4 go into 33? So I have to know my multiples of 4 for this. I know that 4 times 5 from earlier in this paper we said was 20. Okay, so then 4 times 6 is 24. 4 times 7 is 28. 4 times 8 is 32, and that's really close. Can it go in one more time? 4 times 9 is 36. It cannot go in one more time. So 4 fits into 33 without spilling over 8 times, 8 whole times. So now that's the whole number 8. When I use 8 wholes is the same as 32 fourths, but I had 33 of them. So the difference between 32 and 33 is 1. So I have 8 and 1/4. 1/4 is already simplified, so I'm done. Okay. I'm going to do one more problem with you guys, and then I'll help you set up the other ones, but I'm not going to finish them for you. Okay. Let's look at number... Let's look at number 8. Sorry. Okay, number 8. Okay, so we've got mixed numbers that we want to add. So we multiply the denominator and the whole, and then add the numerator. So 5 times 1 is 5, plus 3 is 8 over 5. Okay. Multiply the denominator and the whole, add the numerator. So 6 times 2 is 12, plus 5 is 17. Okay, there was a plus sign between those. I would love to just add straight across the top, and I can't do that until I'm talking about the same thing. The first fraction is talking about fifths, and the second fraction is talking about sixths. So I have to find a common denominator so they can talk about the same thing before I can add straight across. Okay. An easy way to get the same denominator is to, in my first fraction, multiply the denominator by the other denominator. So 5 is the first denominator. Let's multiply it by the second denominator, 6. 6 is the second denominator. Multiply it by the first denominator, 5. Okay. In the fraction 8 over fifths, we're going to multiply the bottom by 6. If I don't multiply the top by the same exact thing, I'll change the value. And I don't want to change the value of the fraction. So let's multiply the top by 6. Because 6 over 6 is 1, and when you multiply by 1, you don't change the value, right? 4 times 1 is 4. 3 times 1 is 3. Negative 10 times 1 is negative 10. 8/5 times 1 is 8/5. I'm just renaming the fraction so it looks like a denominator of 30. Because 6 times 5 is 30. 6 times 8 for the numerator is 48. So I've got 48 over 30. Okay. Plus, oops, we want to multiply the denominator by 5. So we have to multiply the numerator by 5 also. So 6 times 5 is 30 in the denominator. 17 times 5, I'll go off and do some scratch work. 17 times 5. 7 times 5 is 35. 5 times 1 is 5 plus 3 is 8. So 17 times 5 is 85. Okay. Now I've renamed the fractions 8/5 and 17/6 using 30 as the thing I talk about. So instead of talking about 5/5, we're talking about 30ths. And 8/5 is the same as 48/30. Now that both fractions have a 30 in the bottom, I know that I can express their sum as some number of 30ths. Okay. And now that I have the same denominator, I can just add straight across the top. 48 is positive. 85 is positive. Same sign add, different sign subtract. Since those are the same sign, I'm going to add 48 and 85. So I need to do 48 plus 85. 8 and 5 makes 13. 1 and 4 is 5. 5 and 8 is 13. So that's 133. That is a big improper fraction. It just uses big numbers. From here, we need to know our multiples of 30. So we're asking ourselves how many times. I need to do that because this is equal to the right answer, but because the problem gave us mixed numbers, we want to express the answer as mixed numbers. So how many 30s will fit into 133 without going over? So we need to know our multiples of 30. So we've got, I know 30 times 2 is 60. 30 times 3 is 90. 30 times 4 is 120. And 30 times 5 is 150. So 30 can fit into 133 2 times, 3 times, 4 times, but not 5 times. So 30 goes into 133 4 times without spilling over. 4 wholes is the same as 120 30ths. 4 wholes is the same as 120 30ths. I had 133. I had 133. And I'm now saying 4 wholes is going to use 120 of those. So if I find the difference, I'll know how many 30ths I have for the fraction portion of my mixed number. 3 minus 0 is 3. 2 away from 3 is 1. 2 taken away from 3 is 1. And then 1 taken away from 1 is nothing. So I have 13 over 30th. Okay. This is where I'm going to stop the video. Nope, I'm going to charge my computer and set up the other problems. Sorry. We're going to set up the other problems. Hooray. Okay. Now I'll go back and I'll set up using improper fractions, and I'll help you get to a common denominator, but after that you guys need to add the fractions and then put them back as mixed numbers. Okay. So the first fraction is 6 3/8. We multiply and then add the numerator. Multiply denominator and whole, add the numerator. 8 times 6 is 48, plus 3 is 51, all over 8, minus, multiply denominator and whole, add the numerator. So 4 times 2 is 8, plus 1 is 9 fourths. So I know it's supposed to be a minus sign between those. Okay. Those denominators are different. I'll tell you, we can make the 4 look like 8. So I don't have to multiply 4 times 8 and 8 times 4. Because I can make the 4, I can multiply it by 2. And 4 times 2 is 8. If I multiply the bottom by 2, I also have to multiply the top by 2. So now let's rewrite this problem. It's 51 over 8 minus the fraction that has an 8 in the bottom. 9 times 2 is 18. Okay. Looking at number 5, I haven't finished that problem. We're not done. I've just started it and made the denominators the same with you guys. That was maybe at 21 minutes. I'm going to try and find a timestamp for these. 21, go 20, 30. Okay. For number 4. Looking at number 5, this is at 21:49. Looking at number 5, we've got mixed numbers here, so we're going to change them to improper fractions by multiplying the bottom and adding the numerator. Multiply denominator and whole, add the numerator. 10 times 5 is 50, plus 9 is 59, over 10. And then we've got a plus sign. Okay. Multiply denominator and whole, add the numerator. Denominator times, so 5 times 8 is 40, plus 2 is 42, over the denominator 5. Okay. Those denominators are not the same, so we cannot add them. But I can make them the same by multiplying the bottom numbers by something. If you multiply 5 times 2, you'll get 10. So then you have to multiply the top by 2 also. Okay. Looking at number 6, 2251. Okay. So we've got to make them, we're going to make them improper fractions. So 8 times 3 plus 5, denominator times whole plus numerator. 8 times 3 is 24, plus 5 is 29. Okay. Minus denominator times whole plus numerator. So 8 times 2 is 16, plus 7 is 16 plus 7 is 23 over 8. Those denominators are the same. Since you're talking about 8s and you're talking about 8s, you know that you can make your answer talk about 8s. Number 7 at 2342. Okay. We've got mixed numbers and we want to make them improper fractions. So we multiply denominator times whole, add the numerator. 12 times 7 is 70 for the 10. 12 is the same as 10 and 2. So I've got 7 times 10 is 70. 7 times 2 is 14. 70 and 14 make 84. So 84 plus 5 is 89 over 12. And then minus, multiply denominator and whole, add the numerator. So 4 times 3 is 12, plus 3 is 15 over 4. Those denominators are not the same, but you can multiply 4 times 3. If you multiply 4 times 3, you'll get 12, and then the denominators will be the same. If you multiply the bottom, you have to multiply the top. So after you rename that fraction, you'll have two fractions that have 12 in the bottom, so then you can add and subtract like normal. This is going to now be 2507 for number 9. Okay. Number 9 has a whole number minus a mixed number. A whole number is going to be 6 over 1. Okay. And then, so I've got 6 over 1. And then now I've got a mixed number, so minus between them. And then the mixed number is multiply the denominator and the whole part, add the numerator. So 4 times 2 is 8, plus 3 is 11 over 4. Now, those denominators are not the same, but you can multiply 1 times 4, and you'll get the same denominator as the other fraction, 4, because 1 times 4 is 4. So we'll multiply the top by 4. That means I can rewrite this problem as 24 over 4 minus 11 over 4. Right? Okay, and then now number 10 at 2626. Okay. Number 10 says 3 3/4 minus 1 3/5. Multiply denominator, add the numerator. So 4 times 3 is 12, plus 3 is 15 over 4. Minus denominator times whole plus numerator. 5 times 1 is 5, plus 3 is 8, so 8 over 5. Okay, I've got 15/4 minus 8/5. I can't multiply 4 by anything to get 5, and I can't multiply 5 by anything to get 4, but I can say 4 times 5 is 20.